So before we get into the notes themselves, there's one main important thing that I wanted to bring up with you guys, which I will show you here in just a second. Here we go. Let's see this one. Okay, that's better. Alrighty. So besides the kind of normal stuff that we have going on this week, like you had your question yesterday, and then we have some notes for Tuesday and for Thursday, and we've got some assignments coming up. Also, for this week, the one big change is that there's also going to be a midterm. So yes, even though we're online, we're still doing tests in the classes. Luckily, these tests are a little bit easier to take than the normal in-person ones. And so the first test that we're going to take in IPC class this term is our midterm exam. So the midterm is set up similar to kind of your classic everyday assignment, but with a couple key differences. The main one is that it will be posted tomorrow morning. So Wednesday morning is the first day where you'll be able to start working on it. But it won't be due, you won't have to turn it in until the end of the day, Friday. So you have all day on Wednesday, all day on Thursday, and all day on Friday in order to work on the exam. The midterm covers everything that we have talked about so far in this class, from the solids and liquids and gases, to the atoms and electron shells, to even to the stuff that we're going to talk about this week with the chemical bonds and the mixtures and compounds. All of that stuff will be on the exam. So some of the stuff that's going to be on the exam, even though it's posted on Wednesday, we won't actually go over it together as a class until Thursday. So make sure to keep that in mind when you are working on it. Just like with any of your other assignments, there's the Google Forms version and the Google Docs version. The Google Forms version is a little bit different than the other ones, just because I have it separated out into sections. So like when you first open it up, it'll just have a place where you can put in your name right here, just so that it helps me keep track of who's turning in which assignment. Then you hit next, and then it brings up a second group of questions. And so you go through and answer all those. And then you hit next, and you'll go to a third group of questions. So your exam won't be finished and it won't be turned in until you get to the very end and you hit the submit button, just like you would for any other Google Form assignment. The Google Doc assignment is pretty much just like the other Google Docs assignment. You have a big worksheet to work on. For multiple choice questions, you can highlight your answer, you can bold your answer, you can write your answer at like the end of the question, whatever one works for you. There's also some fill in the blank type questions. There's some short response style questions. So all sorts of stuff, all sorts of different question types that you guys will be answering. But again, just like with everything else, the Google Form and the Google Doc versions are the exact same questions presented in the exact same order. They have the exact same answer choices. So whichever one that you want to work on is totally up to you. Again, it will go live on Wednesday. So tomorrow is the first day that you can start working on it. But it is not due until the end of the day on Friday. So you have 3 full days to work on the midterm. The main things that I would recommend while you're taking the midterm is make sure that you take some time while you're working on it, read each question carefully. There's a lot of people who usually lose points here and there on these midterms because they didn't fully read the question, and so they didn't fully understand what type of answer they're supposed to give. Obviously, since it is a midterm, it is a test, I can't directly help you answer the questions. But if you're stuck on a question and you're really confused and you're not quite sure what it is asking, you can reach out to me and say, hey, Mr. Stanley, on this question on the midterm, I don't really understand what it's asking or what my answer should be. And I can do my best to kind of help you get unstuck without actually giving away the answer to you. So again, that midterm is coming up on Wednesday. And you have 3 days to work on it because it is multiple questions. It's, I think, a total of 21 or 22 questions on it. So it might take you a little while to work on, hence the 3 days to do it. But it is worth a good amount of your grade in this class. So make sure that you work on it and take it seriously and get it turned in by Friday. All right. Anybody have any questions about the upcoming midterm before we get started on our notes today? Yeah, Aaliyah.
Are we allowed to use like notes if we took any or no?
Yep. You have the whole Google Classroom open to you. So if you have your own notes that you want to use and reference while you're going through it, that's fine. If you want to go back and look through notes that got posted on the Google Classroom, that is totally fine as well. So yeah, since it is virtual, since it is online, it is essentially like an open note test. All right, Brandy, question.
Do you have any tutoring for anything that we missed?
I don't have any specific tutoring hours set up, but you can always reach out to me and like send me an email or a text and schedule some time, and I'm totally happy to meet with you like one-on-one or in a small group and go over some stuff, some of the old notes.
All right.
Yeah, so I definitely am happy to provide tutoring. You just have to reach out to me and set it up. All right, good questions. Any other questions before we move on? All righty. So like I was saying at the beginning of class, today we're going to keep talking about atoms and molecules and stuff like that. And we're going to be talking about chemical bonds, which are not that kind of bond. They're not this kind of bond either, as fun as that would be.
Oh, darn.
I know. But we are talking about chemical bonds. So the way that atoms essentially stick to one another, how atoms become chemically combined with other atoms. They do it by making chemical bonds between them. And today we're going to talk about kind of exactly why they do that and how that works, what that process looks like for different atoms. All right, so we've been talking about our atoms a lot in the past couple days on this class. Here we have a helium atom. So we've got some particles in the middle here, and we've got some particles on the outside here. So what are these positively charged particles in the middle of the atom called?
Positive and negative?
Electrons, right? Or no?
So electrons are one of them, but they're not these positive guys in the middle.
Protons?
Protons. So protons are positive and protons are in the nucleus, which is like this middle area. So we've got 2 protons in helium. What about these kind of gray neutral guys that are hanging out in the nucleus as well? What are our neutral particles called?
Neutrons?
Neutrons. There you go. You got it. Neutral for neutrons. So we've got the protons and the neutrons, and they're hanging out together in the nucleus right here. And then what about these little negative guys that are zooming around the outside of helium? What are these negative ones called?
Electron.
Electrons. Exactly. The electrons are on the outside part of the atom. Like we talked about the other day, they're on these shells. And so today we're especially going to be focusing on these electrons and what they are doing while they are out on those shells. So a couple things that we're going to recall about these electron shells. We talked about how the atomic number, the number of protons, is equal to the number of electrons. So we want an equal number of positive and negative charges. So same protons as electrons. And that they occur at these certain electron shells. So they're not just flying around all over the place on the outside of the electrons. They're organized in a very specific way. They're at these different energy levels of the shells. So how many electrons that an atom has on its shells are going to determine how that atom reacts with other atoms. So today we're really going to look at how do these electrons interact with each other when different atoms come together. So we mentioned some rules about electrons and how they are organized that some people remembered for the question on Monday and some people had a little bit of trouble with. So the first electron shell can hold 2 electrons. And then the ones after that can hold up to 8. So the second shell can hold 8. The third shell can hold 8. We didn't really talk about any bigger shells, but I think those can hold 8 as well. So the first one is 2, and the rest of them are 8. The one thing that people probably most often get wrong about the electrons and electron shells is that when you're trying to Google answers, which I would normally recommend Googling against Googling answers, especially for the midterm, because the answer that Google might give you might not exactly be lined up with what we talked about in class. So for example, I have a feeling that on the question that I posted for yesterday, some people Googled how many electrons are on the third shell, and Google tells them 18, because Google thinks you're asking how many electrons are on all 3 shells together, because you have 2 on the first shell, and 8 on the second shell, and 8 on the third shell. 2 plus 8 is 10, plus 8 is 18. So 3 shells of electrons in total have 18, but the third shell itself can only hold 8. So that's my little rant against Googling answers in your Excel Center classes. Sometimes it will work, but sometimes it might give you a wrong answer without realizing it. So just go back and look at these notes. You can always go back and look at them. Now, one thing that we didn't talk about on Thursday was this idea of valence electrons. And valence electrons is just a fancy name that scientists give to the electrons that are on the outermost shell of the atom. So if it's an atom like oxygen that only has 2 shells, the valence electrons are the ones on the second shell. If you're an atom like aluminum and you have 3 shells, your valence electrons are the ones on the third shell. So we're going to talk a lot about valence electrons today because these valence electrons are the ones that are interacting when the atoms come together, when the atoms react with each other. It's these valence electrons that are doing all of that reacting. So 2, 8, and 8 is our electron number rules. And whatever the outside shell of an atom is, we call those electrons valence electrons. So for some more examples, hydrogen right here, the super tiniest atom, has 1 electron on its first shell. So you could also say it has 1 valence electron. Carbon has an atomic number of 6. So there's 2 electrons on the first shell and then 4 electrons on the second. Since carbon only has 2 shells, carbon has 4 valence electrons. Nitrogen has 1 more than carbon. It has 7 electrons. So it has 5 valence electrons. And oxygen has 1 more than nitrogen and 2 more than carbon. So there's 2 on the first shell and 6 on the second shell for oxygen. So oxygen has 6 valence electrons. So maximum of 2 on the first shell, maximum of 8 on the second shell, and however many outer shell electrons you have, those are your valence electrons. So carbon's got 4 valence electrons. Nitrogen has 1, 2, 3, 4, 5 valence electrons. And oxygen has 1, 2, 3, 4, 5, 6 valence electrons. So valence electrons, first major important term to remember. Other major thing that we're going to talk about today is something called the Octet Rule. So octet, think like octagon. It means like 8 or like octopus. So the Octet Rule says that atoms would like to have 8 electrons on their outer shells. So it's called the Octet Rule because for the most part, unless you're hydrogen or helium, which are really, really small, all other atoms can have a maximum of 8 electrons on their outer shell. So the Octet Rule says that atoms want to have those 8 electrons. So they'll gain, lose, or share electrons in order so that they can get up to that magic number of 8. So what this means is that an atom like carbon, which has 4 out of the 8 spots filled on its outer shell, would like to gain 4 electrons, right? It has 4 electrons essentially missing from its outer shell. It's only got 4 on there. So in order to satisfy the Octet Rule, carbon would have to gain 4 more electrons. Nitrogen has 5 electrons on its outer shell. So nitrogen would like to gain 3 electrons. So we have these kind of empty 3 spots for electrons. And then finally, oxygen has 6 outer shell electrons. So to get up to that 8, it would like to gain 2 electrons. So the Octet Rule is just a way of saying atoms want to have 8 electrons on their outer shell. So when they react and form bonds with other atoms, they're going to do so in a way that gets them to that 8 electron number. So in the case of these 3 atoms, they want to gain electrons in order to fill up their second shell. So carbon wants 4 more electrons, nitrogen wants 3 more electrons, and oxygen wants 2 more electrons. So whatever the original number of valence electrons is that an atom has, it wants to add more onto that so it can get up to 8. And that's what the Octet Rule is saying. All right, so these ideas of valence electrons and the Octet Rule are going to be kind of really big ideas as we move forward. So does anybody have any questions so far on what are valence electrons or what does the Octet Rule mean?
Guess not.
Gonna say doesn't sound like it so far. All right. So we have these outer valence electrons, and we know we want there to be 8 of them on the outside. So here's kind of another way of looking at some of those atoms. Like these were the ones that we were just looking at over here. So like carbon wants to gain 4 electrons, nitrogen wants to gain 5, oxygen wants to gain, or nitrogen wants to gain 3, oxygen wants to gain 2. The cool thing about the periodic table is if you go down by row, so if you go down one row from carbon to silicon, sure, silicon has more electrons in total than carbon, but the cool thing is that silicon has the exact same amount of valence electrons as carbon. So what that means is that we said carbon has 1, 2, 3, 4 electrons on its outer shell. Silicon also has 1, 2, 3, 4 electrons on its outer shell. So the only difference is that carbon has 4 on the second shell and silicon has 4 on the third shell. But when we're talking about valence electrons, it doesn't matter if we're talking about the second shell or the third shell. All that matters is that that is the outside shell. So carbon's second shell is its outside shell. Silicon's third shell is its outside shell. Same thing with like oxygen over here, right? So oxygen has 6 valence electrons on its second shell. Sulfur has a full second shell, but sulfur has 1, 2, 3, 4, 5, 6 valence electrons on its third shell. So oxygen and sulfur have the same number of valence electrons. It just is different on the shell that those valence electrons are on. So just wanted to illustrate that whenever we talk about valence electrons, we're talking about the outermost shell, and we're remembering that those atoms want to have 8 electrons on their outer shell. Right, so if we look at things like neon over here and argon, neon has 8 electrons on its outer shell, and argon has 8 electrons on its outer shell. So neon and argon are both not going, they already have satisfied the octet rule. They've already got 8 electrons on here. So they don't want to mix with any other atoms over here. They're totally happy. They've got all the electrons they need. So they're not going to be doing any reacting. So valence electrons on the outer shell. The octet rule says that we want 8 on there, or we want at least a full outer shell. So that means that if you remember on the octet rule, we also mentioned that sometimes we might have to lose electrons in order to get to a full shell. So things like carbon or nitrogen or sulfur or chlorine are going to gain electrons in order to try and fill up that outer shell. But things like lithium or sodium or magnesium might lose electrons. So like sodium over here only has 1 valence electron. Magnesium has 2 valence electrons. So it'd be a little bit easier for sodium to lose this 1 electron and have a full outer shell on the second shell than to try and gain 7 more electrons. So we're going to see this come into play when we talk about a certain type of chemical bond in a little bit. But again, main thing to remember is that valence electrons are on the outside, and the octet rule says that whatever our outside shell is, we want it to have 8 electrons. This is just another way of showing atoms by showing their valence electrons. I just wanted to show you in case it comes up on like a future exam or something that you have to take. So like we talked about, carbon has 4 valence electrons. So a carbon dot structure has just 1, 2, 3, 4 little dots on it. Oxygen has 6, so there's 1, 2, 3, 4, 5, 6 little dots. Sodium has 1 valence electron, so it's got 1 little dot. So the little dots around the symbol just represent the valence shell electrons, instead of showing all of like the first shell and the second shell if you don't need to. All right, so chemical bonds are when atoms form bonds with each other when they're trying to fill up their electron shells, when they're trying to satisfy that octet rule. So there's 3 kind of general chemical bonds that are out there, but there's only 2 that we're really gonna focus on today. So ionic bonds and covalent bonds are the main ones that we are going to look at. Metallic bonds we'll talk about very briefly, but you don't really need to know very much about those. But ionic and covalent are what we're really gonna hit hard today. So ionic bonds are when we transfer electrons from one atom to another, meaning one atom gives away its electron and the other atom takes it. And covalent bonds are when atoms share electrons between them. So they both use the same electrons to try and get to a full outer shell. So we're going to focus on ionic bonds first. So when you think about ionic bonds, I want you to think transferring electrons, giving away and taking electrons. That's what's happening in an ionic bond. And when that transfer happens, when one atom gives away or takes the electron, it causes that bond to form. It causes the atoms to become bonded together, to become chemically stuck together, essentially, or fused together down at the atomic level. That's what's happening in an ionic bond. We're giving away and taking electrons. So in ionic bonds, I don't really worry about electronegativity. We're not really going to talk about that in this class. But we are going to talk about transferring electrons. Again, ionic is transferring, giving and taking. So the way that it forms these bonds when we transfer electrons is it creates something called ions, which we're going to talk about here in just a second. So we're giving away, we're transferring our electrons. So between things like sodium chloride, also known as table salt. So the salt that you use to put on your food and stuff is sodium chloride, which is formed by an ionic bond. Calcium chloride, also formed by an atomic bond. This is potassium oxide. So that is also formed by an atomic bond. I guess the only thing I would mention also about it is that ionic bonds tend to be between metals and nonmetals. So remember we talked about on Thursday, metals are kind of in the middle and center of the periodic table. So they're shiny, they're squishable, they're conductive, all that good stuff. And then nonmetals are way over on like the right-hand side of the periodic table. Things like carbon and nitrogen and oxygen tend to be gases, all that good stuff. So like sodium is a metal and chlorine is a nonmetal. Calcium is a metal, chlorine is a nonmetal. Potassium is a metal and oxygen is a nonmetal. So the way that ionic bonds work, and I'm sorry I don't really have any way of pausing this little animation. So but on one side we have sodium, which is Na. And on the other side, we have chlorine, which is Cl. And if you remember from a little bit ago, let's go back to that table. We saw that sodium has 1 valence electron. And way over here, chlorine has 1, 2, 3, 4, 5, 6, 7 valence electrons. So sodium's got 1 electron, chlorine has 7. So what can they do in order to make sure that their outer shell has 8 electrons? Sodium is going to give away that 1 electron that's on its valence shell. So the yellow dot here is the sodium electron. And the red dots are the chlorine electrons. Again, we have 1 on sodium, and we have 1, 2, 3, 4, 5, 6, 7 on chlorine. So when sodium gives away its electron, now it doesn't have a third shell anymore, but it has a full second shell of 8. And chlorine, now instead of having 7 electrons around its valence shell, now it has 8 electrons. So both of them are satisfying that octet rule. Sodium is doing it by giving away an electron so that its outer shell is the second shell that has 8 electrons on it already. So that's where its 8 comes from. And chlorine's 8 comes from adding that 1 electron so that now, instead of having 7 outer third shell electrons, it has 8 because it took that 1 from sodium. So that's why these atoms react together in this ionic bond. Sodium gives away the electron and chlorine takes the electron. We're transferring the electron from sodium to chlorine. So now sodium has a full second shell and chlorine has a full third shell. So it's great and all that they're given and taken and filling up those shells, but then why doesn't sodium and chlorine, why don't they just split and leave after that? Why do they bond together? What makes them stick together? Oh, I always forget that this is in here. Something kind of funny I found, it's almost like there's one dog, like this one big dog, that wants to take the bone away from the little dog. So the little dog doesn't have any bones anymore, and the big dog has all the bones. So those bones are the electrons. The one atom took the electrons away from the other atom. So in this case, the reason that these guys are sticking together, well, if you're a dog, maybe that the sodium dog is kind of hoping that it can get back to those chlorine atom dogs. But the real reason why sodium and chlorine stick together after that transfer has to do with the fact that now they're no longer neutral atoms. So remember, we talked about how neutral atoms are when you have equal protons and electrons, right? The atomic number is the proton number and also the electron number. So before, sodium had 11 protons and 11 electrons. And chlorine had 17 protons and 17 electrons. Well, sodium lost an electron to chlorine. And does anybody remember what kind of charge that electrons have on them? Are they positive charges? Are they neutral? Are they negative charges? What types of charges are on electrons?
Ain't they negative?
Negative, bingo. So when sodium loses that electron, it loses that negative. So sodium becomes a little bit more positive, hence the little plus right here. Chlorine, on the other hand, gained an electron. It gained this negative charge. So chlorine became a little bit more negative. So when they become a little bit more positive or a little bit more negative, we call those ions. That's just kind of a general term for this is a little bit more positive or this one's a little bit more negative. And in science, the old idiom of opposites attract is actually true. opposite magnetic fields will attract to each other on a magnet, and opposite electrical charges will attract to each other as well. So when the sodium becomes positive and the chlorine becomes negative, that makes them want to stick together because the positive and the negative are attracted to each other. So it's almost like now there are two little magnets that are sitting next to each other and they become stuck together. That's where this ionic bond comes from. When we gave away the electron and chlorine took it, they became charged. And when they became charged, they became attracted to each other. So the positive sodium and the negative chlorine stick together because of that attraction between positive and negative. So that's why ionic bonds work. Not only do the atoms now have 8 outer shell electrons, sodium has 8 on its second shell, chlorine has 8 on its third shell, so they're happy that way. But now the atoms are bonded together because of that attraction between the positive and negative charges. So ionic bonds, we're transferring electrons, and then the new atoms are attracted to each other. They become stuck together because of that attraction. Like I said, sodium chloride is salt, is table salt. And so when you get tons and tons of sodium and chlorine ions that become stuck together, they can form these big clumps of what becomes table salt. So all of these little big chloride and little sodiums are all stuck together with those ionic bonds. So that is kind of what's happening in fast motion right here. The sodium gives away its yellow electron, the chlorine takes the yellow electron, and then the sodium becomes positive, chlorine becomes negative, and electrostatic attraction just means that the positive and the negative are now attracted to each other. So ionic bond is giving away electrons. It's losing or gaining electrons in order to get to that full outer shell. Usually you get a charge in the process and you become stuck together with the electron with the atom that transferred the electron. All right. So I would say ionic bonds are probably the more complex of the two that we're going to talk about today. So does anybody have any questions, any ionic bond related questions they want me to go back and talk about again?
And when it's connecting, oh no, never mind. Never mind.
Gotcha. All right, thanks, Leah. So that is an ionic bond where one atom gives away the electron and the other atom takes the electron. The other version of bonding that we can have is covalent bonding. And the reason why it's called a covalent bond is it's a covalent bond, meaning that we're sharing valence shell electrons. So covalent bonding is all about sharing electrons. Both atoms are using the same set of electrons. So instead of one losing and one gaining, instead it's like they're both using the electron at the same time. So covalent bonding is all about sharing. So covalent bonds tend to happen between two or more nonmetals. So like oxygen likes to make covalent bonds with itself a whole lot, which is where O2. Carbon dioxide, CO2, is formed by a covalent bond. This is C and O, both are nonmetals. Water is another very popular covalent bond. So hydrogen is nonmetal and oxygen is nonmetal. This is, I'm trying to remember C2H6. I think it's either propane or butane, one of those. So 2 carbons and 6 hydrogen atoms together, those are all covalent bonds between there. And it's all about sharing these electron pairs. So 1 or more atoms sharing their electrons together. So here is a really good example. So this is the atom CH4, 1 carbon, 4 hydrogens. So remember, we said that carbon has 4 valence shell electrons. It has an atomic number of 6, so there's 2 electrons on the first shell, which you can't see here, but there's 4 electrons on carbon's second shell. So carbon has the blue electrons. So 1, 2, 3, 4 electrons from carbon. Hydrogen is the super little teeny tiny atom. It only has 1 electron on its first shell. So in order to satisfy that octet rule and get to a full outer shell, hydrogen wants 1 more electron because then it has 2 on its first shell and 2 is a full first shell. So hydrogen wants 1 more, and carbon wants 4 more electrons. So it can have 4 of its own, and 4 more total make 8. So carbon will bond with 1 hydrogen. So in a covalent bond, the carbon electron and the hydrogen electron are shared with each other. So it's like we added 1 electron both to hydrogen and to carbon. So now this hydrogen is happy because it has 2 outer shell electrons, but carbon still has 3 spots to go. So it adds another hydrogen. 1 carbon electron, 1 hydrogen electron gets shared. So now this hydrogen is happy, but carbon still has 2 spots to go. We form another covalent bond with hydrogen, 1 hydrogen electron and 1 carbon electron. And then we do that again with this 4th one. So by bonding to 4 hydrogens, each one of these hydrogens shares its electrons with carbon, and carbon shares right back. The hydrogens all get 1 electron shared with them, so they each feel like they have a full set of 2 on their outer shell. Carbon is getting 4 more electrons shared with it. So now carbon feels like it has 8 electrons on its outer shell. So this is how covalent bonding works. Instead of, notice how the hydrogens aren't losing their electron, they're not giving them away to carbon. Instead, they're sharing. They're both using each other's electrons in order to get to that full outer shell. So this can also happen with things like, I'm trying to remember what has 7. I think it's like fluorine. So F, the element F, fluorine, has 7 outer shell electrons. And so fluorine can bond with itself because, and again, I'm sorry, I can't like pause this and break it down, but each one of these atoms has 7 electrons on its outer shell. And so when they bond together, they'll each share that kind of final 7th electron. So one of them has 2, 4, 6, and the other one has 2, 4, 6. And then the 7 from one and the 7 from the other are then shared between the 2. So now each atom feels like 1 more electron got added onto it. So now the left atom feels like it has 8 electrons, and the right atom feels like it has 8 electrons, all because they shared that 1 pair of electrons between them. Again, we're not giving away the electrons. This one is not taking it from the other atom. We are coming together and sharing. And so since we have these shared electrons going on, it basically forces the atoms to be stuck together because they are literally, their valence shells are stuck together because they're both using the same set of electrons. So they're not bonded together because there's a plus and a minus that are attracted, like in ionic bonds. They're bonded together because they're sharing the same set of electrons. So they have to stay next to those electrons, so they're going to stay bonded and stuck together. So that is our covalent bond, where we share valence electrons between two or more atoms. So covalent, we're sharing valence electrons, right? And again, it's all because we're trying to get back to that magical number of, for the most part, 8. So for hydrogen and helium, they want 2 electrons because they only have the 1 shell. But all other atoms want to have that 8 electron outer shell. So some atoms form covalent bonds so that they can share electrons with other atoms and feel like they are at that 8 electron level. All right, does anybody have any covalent electron bond questions?
No.
No, sir. This will be
Seems like it.
recorded, right?
Yep,
Okay.
it is recorded, just like all of them. You bet. All right, so like I said, this one a little bit more straightforward than the ionic one. We're not dealing with electrons giving away and taking and pluses and minuses attracting. It's just literally they're both coming together and then sharing their electrons and then moving on together as like a bonded pair or a bonded group. And then finally, metallic bonds, we're not really going to talk about. These are essentially bonds that hold together instead of nonmetals like we were looking at with the covalent. These are how metals are bonded together. And essentially, when metals become bonded together, they just kind of all share their electrons equally. So it becomes what some people call a sea of electrons or a cloud of electrons. Partially because, like we talked about, metals are very, very good conductors, which means electrons can move really easily across different metals. And so when large amounts of metals become bonded together, the electrons are able to move freely around and through the metals. But like I said, don't worry too much about metallic bonds. We're not really going to talk about those ones. The main ones to focus on are our ionic bonds, where we're transferring the electrons, and our covalent bonds, where we are sharing the electrons. Again, we're only working with the valence shell electrons, those outer shell electrons. And the reason we're making that atoms are making these chemical bonds is that we're trying to satisfy that octet rule. We're trying to make it so that we have 8 valence shell electrons, either on our second shell or on our third shell, or even higher if you're looking at bigger and bigger atoms. So whatever our outer shell is, we want there to be 8 electrons in there. Whether you have to gain electrons, whether you have to lose electrons, whether you're going to share electrons with your neighbor, you want there to be 8. All right. Make sure I didn't miss anything important. I don't think I did. Anybody have any final questions about anything that we talked about in the notes so far tonight? The valence shells, the octet rule, or the different types of bonds?
No.
Can you review
Righty.
assignment today?
Yep, just about to go over that right now. So for your assignments this week, I wanted to make them pretty quick and easy to do, since again, you're going to have, starting on Wednesday, that midterm that you're going to be working on. So the Tuesday assignment is just a really quick review of the different types of bonds that we were just talking about. So there's two sets of pictures. There's this first picture up here and this second picture down here. And in each picture, I want you to tell me what type of bond is being pictured in this image. And how can you tell? So what is it about the picture that tells you that a bond, that specific type of bond is being formed?
I love it. But I want to ask you, how can I tell them? How can I tell? I tell this one is capital L and small e and capital F.
So these two atoms are lithium and fluorine are the names of them. And so we have some electron shells right here. Lithium has 2 on its first shell and 1 on its second. And fluorine has 2 and 7. And then based on, essentially I want you to say based on what happened with the electrons, how does that tell you what type of bond that it is? So like we were just talking, if the atoms are, so you can tell, so if you think it is a covalent bond, then it would be because they are sharing electrons. And if you think it is an ionic bond, it would be because they are transferring the electrons. So for each picture, you have to determine, okay, what type of bond is this? And then tell me it's a covalent bond because this is what's happening, or this is an ionic bond because this is what's happening.
Yep.
All right, does that help you out a little bit more, Dewey? Does that kind of explain things a little bit better?
Yes.
All right, excellent. Anybody else have any questions about the homework that got posted for today? Again, only 4 questions, shouldn't hopefully not take you too long. And then same thing with the daily assignment for tomorrow is just another example of a question. This one is asking about the relationship between the Octet Rule and the Octet Rule and valence electrons. So not a worksheet or an assignment that you have to do, just another kind of daily question to answer. And then, like I said, tomorrow also is when the midterm will be going live. Again, for the midterm, it is up tomorrow, but you have until the end of the day on Friday to finish it and turn it in. So you have all day Wednesday, all day Thursday, and all day Friday to work on and complete the midterm. And like people were asking about before, it is open notes, so you're free to go back and look at notes that were posted earlier in the class while you're working on the midterm. And if you ever get stuck, if you're ever confused about what a question is asking, you're always free to reach out to me as well.
Awesome.